All right, let's try a few more. All right, so we're looking here. We're going to find the, reminder, we're going to find the derivative of the inverse and then evaluate and write the equation of the tangent line. All right, so we want to find f inverse of 5, right? Because this is our inverse value, all right? And we're looking for the derivative of that. So that's going to be 1 over f prime f inverse of 5. If we plug in 5, actually, instead of me having to keep writing this, I'm just going to put an equal sign. So that's going to be 1 over f prime of f of 0. All right, now let's find the derivative, because we didn't do that yet. All right, and I'll put it up here. So f prime of x is equal to, all right, so we have e. We know with e it's going to be an exact copy times the derivative of the exponent. The derivative of negative 9x cubed would be negative 27x squared. All right, so this is the derivative of negative 2x is going to be negative 2, so that'll be negative 2e to the negative 2x minus 27x squared. All right, and so now we're going to put that in the denominator and plug in the 0. So that's going to be equal to 1 over negative 2e to the negative 2 times 0 power minus 27 times 0 squared. All right, well, 27 times 0, that's just 0. So we're going to have e to the negative 2 times 0. That's just e to the 0 power. And that e to the 0 power is 1. So we're just going to have in the denominator a negative 2. So this is going to be equal to, and I'll write the equation, the whole equation. So the derivative of the inverse when x is 5 is equal to negative 1/2. And then here's our equation of our tangent line. We already have the values for the derivative. All right, so that's going to be y equals, because I don't need the minus 0, negative 1/2 x minus 5. So that'll be y equals negative 1/2 x plus 5/2. There we go. That one's done. Let's try the next one. All right, so let's find the derivative. All right, so to find the derivative, we have f prime of x equals, it's a nice easy power rule, 7x to the 6th plus 2. Right? Derivative of 2x is 2, derivative of 9 is 0. All right, so f in the derivative of f inverse of 12 is going to be 1 over f prime f inverse of 12. So that's going to be 1 over, if we plug in 12 into the inverse, we're going to have 1 coming out. So f prime of 1, and that's going to give us 1 divided by 7 times 1 to the 6th power plus 2. Right? So that's just going to be equal to 1/9. So the derivative of f inverse at x equals 12 is equal to 1/9. All right, now we can write the equation of the tangent line. All right, so that's going to be y minus 1 equals 1/9 times x minus 12. Or y equals 1, oops, lost a 1 there. Y equals 1/9 x minus 12 plus 1. That's good enough. All right, now let's find the next one. Right now we have a product rule. All right, so u is x to the 5/3 If we take the derivative of that, that's going to be 5/3 x to the 2/3 power. Right? And then v is e to the x squared. The derivative of that is going to be e to the x squared times the derivative of x squared. Derivative of x squared is 2x. So this is just going to be equal to 2x e to the x squared. I think you can see that one okay. What happened to my x on the derivative? There we go. There we go. Close enough. Okay. All right, so let's find our derivative. So f prime of x equals the first, which is x to the 5/3, times the derivative of the second, which is 2x e to the x squared, and then plus the second, which is e to the x squared times the derivative of the first. So plus 5/3 x to the 2/3 times e to the x squared. Let's simplify this a little bit. Let's make that 2 in front. Let's put the e in front as, we'll combine the x's. So we'll put the x's first. Well, we have x to the 5/3 times x. All right, so when you multiply like bases raised to a power, you add the exponents. So 5/3 plus 3/3 is 8/3. And then e to the x squared plus 5/3 x to the 2/3 e to the x squared. Now we can factor out some things that might make us a little easier. We could factor out the x's, or we could just factor out e to the x squared. All right, maybe I'll just factor out e to the x squared on this one. All right, so factor out e to the x squared. That's going to leave us with 2x to the 8/3 power, especially because we're going to be plugging in a 1. 2x to the 8/3 power plus 5/3 x to the 2/3 power. All right, so now I'll do the derivative over here. All right, so maybe I should. So all of this, we took a lot of space just finding the derivative of that function. All right, so this was just the derivative of f prime of x. Now let's find the derivative of the inverse. All right, so that's going to be, and we're evaluating that at e. All right, so that's going to be 1 over the derivative evaluated for the inverse. Plug in e to the derivative, or into the inverse, you get 1. So this is 1 over f prime of 1. All right, so now we're just going to plug in 1. All right, so that's going to give us, boy, I could use a little bit more space. Maybe if I just move this over a bit. All right, so that's going to give us, we'll finish it over here. One over, so then we have e to the 1 squared. It kind of looks like, I don't know what that looks like. E to the 1 squared times 2 times 1 to the 8/3 whoops, sorry, we need just a little bit more space. My line must have broke up. All right. Boy, this is connected weird. Okay. Plus, and this is all in parentheses, 5/3, 1 to the 2/3. Oh, just need like a centimeter. Two-thirds. There we go. All right, so that's going to be 1 over, all right, so we've got E, and then we've got 2 plus 5/3. All right, that's all we got. So 2 is 6/3, that's going to be 11/3. All right, so if you've got 11/3 in the denominator, that's going to be equal to 3 over 11E. There's our slope. All right, so now let's put the equation of the tangent line right here. Since we have a little bit of space. It's color coded, so I think it still makes sense. I don't know, somewhere I just needed a little bit more space. Maybe I should have had a screen just for this one. All right, so we have y minus 1 equals 3 over 11 e, and the e is in the denominator, times x minus e. Actually, that's going to kind of cancel out kind of nicely. Well, there'd still be an e in the denominator. We'll just leave it like this, except let's move the 1 over. Y equals 3 over 11 e times x minus e plus 1. The 1e would cancel. All right, and there's our equation of our tangent line. All right, we found this one. It could be a little neater, but it's okay. One last problem. A function and its derivative take on the values shown in the table. If g is the inverse of f, find g prime of 6. All right, so g prime of 6 is the same as f inverse of 6 after we take the derivative. All right, and actually we could just say, let me say something else first. So g of 6 is equal to the inverse of f at 6. And that does mean if the functions are equal, their derivatives are equal. Well, how do we find the derivative of an inverse? Right, we take 1 over the derivative evaluated for the inverse. All right, so if the function is 6, excuse me, that's a yes. So if the inverse is 6, right? The y value is going to be 2, right? So for f of x has a point 2, 6. F inverse of x has a point 6, 2. So if we plug in 6, 2 comes out. So we have g prime of 6 equals 1 over f prime of 2. All right, well, if we take the derivative when x is 2, we're going to get 1/3. All right, so now we have g prime of 6 equals 1 over 1/3. Well, all right, if you got 1/3 in the denominator, that's the same as 3. And there we go. So that's the end of this problem. All right, so I think the trickiest thing is not so much finding how to find the derivative, it's which point to plug in. To me, that gets a little tricky, mixing up my x's and y's. So hopefully, just take your time, All right, and when you're doing these, and if you have questions, let me know. Otherwise, have a great day, and I'll see you soon. Bye for now.